Hey guys, I'm going to try making a video lesson to teach you about the first two gas laws. I think most of you have worked these before with Mr. Pickett, but I'm going to try to instruct via video like I might do in class. So please make sure that you have the other activity prepared. And that's the one that's going to be in Google Classroom. It's called Pandemic Gas Laws #1. And that's the one that we're going to be working Wednesday, and it'll be due Wednesday, April 29th. But right now I'm going to kind of teach you the process for solving Boyles Law and Charles Law. So let me go ahead and share my screen with the PowerPoint for gas laws. Some of you were actually at my Zoom class where I introduced this a few weeks ago. These first few slides are things that you're probably familiar with from middle school. And I'm not going to read them to you, but I do recommend that you open this PowerPoint and read it. It will also be in the Google Classroom. But the most important takeaway from this first slide is that what's super unique about gases is that 1 mole of a gas can occupy a specific volume as long as you know that it's at standard temperature and pressure. Standard temperature is 0 degrees Celsius or 273 Kelvin, those are the same temperatures, or 1 atmosphere of pressure. And if a gas has 1 mole of a gas at 273 Kelvin and 1 atmosphere, it will occupy 22.4 liters. So how that is really handy is that as long as you know the temperature, the pressure, and the amount of gas, you can figure out its volume. Just to recap, we do use the abbreviation STP frequently in these problems. And STP just means that one of your set of conditions is standard temperature and pressure. Standard temperature is 0 degrees Celsius or 273 Kelvin. And standard pressure, you can see there's several in this PowerPoint that are mentioned. 1 atmosphere, 101.325 kilopascals. Those two are the ones that we use the most frequently. But there's also 1.013 bars that's used like in scuba diving. And then millimeters mercury is used in weather when we're talking about barometric pressure. But you will need to refer back to that. So in the problem, if it mentions standard temperature or standard pressure, it's referring to these values. These are the characteristics of an idle gas. Once again, read them over. I'm not going to read them to you. And one last thing as we jump into doing these first gas laws together, and that is that you can't ever use Celsius in a gas law problem. If you're provided Celsius in the problem, though, it's pretty easy to get it to Kelvin just by adding 273 to that number. For example, if I was at 0 degrees Celsius, I would add 273 to that, and that would be 273 Kelvin. If I was at 10 degrees Celsius, add 273, that's 283 Kelvin. So the first law we're going to look at is Charles Law. And we can express Charles Law as a statement, and that just says that the volume and temperature of a gas are directly proportional. Or we can describe it by a formula, and that's your initial volume, V1, divided by your initial temperature, T1, will be equal to your new volume and your new temperature. If you've done the virtual lab on Charles Law, that was why I had you taking V1, or the volume divided by the temperature each time, because they should have all been equal, because the volume and temperature at one scenario will be equal to the new volume and a new temperature at a second scenario. So let's try one together. Here is our first problem. A gas has a temperature of 120 degrees Celsius and a volume of 1.4 liters. What is its new volume if the temperature is increased to 240 degrees Celsius? So first, what I'm going to do is I'm going to think, what's my initial set of conditions? That's going to be my V1 divided by T1. Well, my initial volume is 1.4 liters. I'm going to write that down. And then I'm going to divide that by my initial temperature. Well, right away we have an issue, right? Is our temperature in Kelvin? No. So if I add 273 to my 120 degrees Celsius, that gives me 373 Kelvin. So that's going to be my V1 divided by T1. And I'm going to set that equal to my new volume, which I don't know, divided by my new temperature. Well, what would my new temperature be? I'd have to take 240 degrees Celsius and add that to 273 to get to Kelvin. So 273 plus 240 will be 513 Kelvin, like so. So once I am ready to solve this, I'm just going to cross multiply and divide. So I'm going to take, crisscross. So I'm going to take 1.4 times 513 and 373 times V2. Like so. And then I'm simply going to isolate my variable, which is my volume. So I'll take 1.4 times 513 divided by that 373. And that gives me a new volume of 1.8 liters. Like so. So
I couldn't find any enabled video skills that can do that. Go to the Alexa app to manage your video skills and devices.
Sorry, Alexa thinks I'm talking to her. I'll have to go turn that off. So my new volume is 1.8 liters. Now let's look at what happened to our temperatures. I was at a temperature of 373 and it jumped up to 513. So my temperature went up. So what do I expect to happen to my volume? Well, remember we said they're directly proportional. If volume goes up, temperature goes up. So I do also expect my volume to go up. Did that happen? Yeah, it went from 1.4 to 1.8. So I am going to put this up where you can see it more closely. Actually, let me stop sharing for a sec. And what you can do with this now is stop the video, use this as your example, and then try the first 3 problems that are Charles Law problems on your worksheet. Okay, so you're back. Let's see how you did. Here are your answers. If you did those first 3 problems correctly, I'm sorry, I'm doing this wrong, aren't I? Let me share my screen. So if you did those correctly, these are the answers you should have gotten. If you didn't get the 58.6 Kelvin on the second one, it's probably because you didn't cross multiply and divide correctly. Sometimes you don't have to cross multiply and divide, but when you're solving for temperature, because it's in the denominator, if you don't take the time to cross multiply and divide, frequently you mess up the math. So the next law we're going to look at is Boyles Law. And Boyles Law, once again, can be expressed as either a statement that says the volume of a gas and its pressure are inversely proportional. In other words, as one goes up, the other goes down by the same factor. Or by a mathematical formula that says the initial pressure times the initial volume will be equal to the new pressure times the new volume. P1V1 equals P2V2. So let's try a problem that's a Boyles Law problem. So on this one, you can see that it says a gas has a volume of 2.5 liters and a pressure of 2.75 atmospheres. What is its new pressure if the volume is decreased to 1.25 liters? So my formula, as we said, is the initial pressure times the initial volume equals the new pressure times the new volume, like so. So my initial pressure in this problem is going to be the 2.75 atmospheres. Now, you may not have dealt a lot with atmospheres yet in your science classes. We use it with pressure. We use it in chemistry quite a bit at this point. But you may not have used it a lot before. So really the only trick for Boyle's problems is recognizing your pressure units, which are atmospheres, or the other pressure unit we use is kilopascals. So my first pressure is 2.75 atmospheres, and my first volume is 2.5 liters. So that's going to go on the left. And then on the right, I'll put my new pressure, which I don't know, that's what I'm looking for, times my new volume, which is 1.25 liters. So now I am ready to actually solve it. So I will simply isolate my variable, which is P2. So I'll divide both sides by 1.25. And I'll find that my new pressure is going to be 5.50 atmospheres when I do the math. So you can take a second and copy that as an example and go ahead and hit pause. Okay, let's see how you did. Let's go back to the PowerPoint and see if you got the right answers. So if you set these up correctly, you should have gotten 0.863 atmospheres, 243 kilopascals, and 18.4 liters. Do make sure you got that, and do make sure you've shown your work on that sheet. Now you have two more to do, and on these I'm not giving you the answers. Those are questions 7 and 8. Those are for me to see if you can get the answer without having the answer, if you can figure out which law to use and how to plug in the values. So that's on you. When you're done with all of that, submit it through Google Classroom. It's going to be due April 29th, as I mentioned. For those of you who would like to see 2 more examples, you can stay on and watch a little more video. I'm going to work 2 more, but for those of you who kind of feel like you've got it, you can finish. And it's been good seeing you. I will have Zoom sessions, short ones, on Wednesday and Thursday if you have questions. As long as I will be meeting during the first 30 minutes of 2A, 3A, I'm sorry, 2B on Wednesday, and then 2A, 3A, and 4A on Thursday if you have questions. So watch this first though, and let me know. And email me too if you have questions. Remember, my office hours are in the morning. So if you email me between 9 and 11:30, I can respond back. You can even ask for a quick video chat if you want, as long as it's not when I'm already in class. So I will let you go for now, for those of you who are done, and for those of you who'd like to see 2 more examples, here we go. So let's look at this first problem. It says a gas is in a 5-liter container at a temperature of 273 Kelvin. What is the temperature if the volume increases to 10 liters? So you'll notice our units are liters and Kelvin, and then a new liters. So which gas law will this be? It'll be the one that has volumes and temperatures. So Charles, V1 divided by T1 equals V2 divided by T2, like so. So what's my initial volume? 5 liters. And what's my initial temperature? Conveniently, it's in Kelvin, so I can just throw that in. And then what's going to be my V2 and T2? Well, I can see that my new temperature is 10 liters, so that's going to go on top in the V2 slot, but I don't know my new temperature. So I'm going to have to put in T2 as my variable. So when I go to solve this, I'm going to want to cross multiply and divide. So 5 liters times T2 equals 273 Kelvin times 10 liters. Like so. And then of course I just need to isolate T2. So I'll divide both sides by 5. And I will find that my new temperature is going to be 546 Kelvin, I think. Let me double check. 273. Yes, 546 Kelvin. So that's how that first problem would be set up and solved. Let's look at the second one. So the second problem says a balloon has a volume of 8 liters at a pressure of 101.325 kilopascals. That's actually standard pressure. What is its volume if its pressure is reduced to 50.66 kilopascals? So this has volume with liters and pressure. So this has to be the Boyles law, which is that pressure 1 times volume 1 equals pressure 2 times volume 2. Like so. So what's my initial pressure? 101.325 kilopascals. And my initial volume was 8 liters. And I'm going to set that equal to my new pressure, which is 50.66 kPas, times my new volume, which I don't know, like so. So now in order to get my volume 2 by itself, I'm going to divide both sides by 50.66. And I will get, let's see, 101.325 times 8 divided by 50.66 gives me 16.0 liters. Like so. So that's 2 extra problems, just if you wanted to see a couple of more demonstrated. Remember, you can tune in on Thursday if you're A day during the first 30 minutes of your class, or Wednesday 2B if you're B day. I'll put that information on Google Classroom. And I hope you guys are doing great. And I hope that you do show in for my Zoom, if only so that I can see your faces and know you're doing okay. Anyways, thanks for tuning in, and I will talk to you later.